Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today. For exam P on probability, Glittery Property Insurance offers an insurance policy covering a loss described by a random variable x that follows a gamma distribution with parameters alpha equal to 3/2 and beta equal to 1/5. Note that if a gamma distribution is obtained as a sum of independent, identically distributed exponential random variables, then the parameter alpha describes the number of those variables added, while beta is their common hazard rate. The policy has a deductible of 10. Find the probability that Glittery Property Insurance will not have to make any payment on this policy. You are given that gamma function evaluated at 3/2 is equal to square root of pi over 2. And here's the solution. So recall that the PDF of gamma distribution is f sub x of x equal to beta to the power alpha x to the alpha minus 1 times e to the minus beta x divided by gamma over alpha for x greater than 0 and f sub x equal to 0 is equal to 0 otherwise. The probability we're looking for is the probability that x is less than 10, which is the integral from 0 to 10 of 1/5 to the power 3/2 times x to the power 3/2 minus 1 times e to the minus x over 5 divided by gamma of 3/2. Now we know the gamma of 3/2, so we put that 1 over square root of pi over 2 in front, and this is multiplied by the integral from 0 to 10 of x over 5 to the power 1/2 times e to the minus x over 5 times 1/5 dx. And we do a substitution. Let u equal to x over 5 to the 1/2, square root of x over 5. Then when x is 0, u is 0. When x is 10, u is equal to square root of 2. And then du is 1/2 times 1/5 times x over 5 to the power negative 1/2 dx. And then the integral we're working with becomes 2 over square root of pi times integral from 0 to square root of 2 of u times e to the minus u squared times 2u du. Okay, so we take this expression e to the minus u squared times 2u du as the differential of e to the minus u squared times 2u differential of v defined by minus e to the minus u squared. Then dv is e to the minus u squared times 2u du. And then we let w to be u, then dw is du. So what we have here is w times dv, and that's equal to u times v, evaluated from the same over the same limits, minus the integral over the same limits of v du. Of course, minus makes it a plus. Everything has a common factor of 2 over square root of pi, so we'll leave it there. And this becomes minus u times e to the minus u squared evaluated from u equal to 0 to u equal to square root of 2, plus the integral from 0 to square root of 2 times e to the minus u squared du. Okay, so we have minus 2 square roots of 2 e to the minus 2 over square root of pi plus integral from 0 to square root of 2 over 2 square root of pi times e to the minus u squared du. Now we let u equal to square root of 2, z over square root of 2, I'm sorry. Then when u is 0, z is 0, and when u is square root of 2, z is 2. And then du would be dz over square root of 2, so that square root of 2 times du is dz. So this is integration by substitution. And this expression becomes then minus 2 square roots of 2 e to the minus the negative 2, e to the negative 2 over square root of pi, plus 2 integrals from 0 to 2 of 1 over square root of 2 pi times e to the minus 1 half z squared dz. Well, of course, what you see here is the integral of the PDF of the standard normal distribution. So what we have here is minus 2 square roots of 2 e to the minus 2 over square root of pi plus 2 times phi, the CDF of the standard normal distribution, minus phi of 2 minus phi of 0, where phi again is the cumulative distribution function of the standard normal distribution. So we look up the values of phi of 2 and phi of 0. Well, phi of 0 is 0.5. We don't need to look up anything, but phi of 2 is 0.9772 from the table on the test. So we plug that in, and we do the calculation of everything, and we get approximately 0.7384, which is answer E. Please remember, this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.